Starting a new topic called differential calculus. The first thing we're going to look at is horizontal lines in the form y equals a constant. When we look at the lines y equals 4, y equals 2 and y equals minus 3, we see that line y equals 4 passes through 4 on the y-axis, the line y equals 2 passes through 2 on the y-axis, and the line y equals minus 3 passes through minus 3 on the y-axis. Because these lines are flat, the slope of each line is equal to 0. The slope of each line is equal to 0. So therefore, if y is equal to 4, then dy dx is equal to 0. The slope is equal to 0. If y is equal to 2, then the slope is equal to 0. Because y is equal to 2 is a horizontal line, and the slope of any horizontal line is always equal to 0. And here we've got it again. If y is equal to minus 3, then the slope, dy dx, is equal to 0. The new coding for slope is dy dx. dy dx means the same as slope. We will now consider lines of the form y equals mx plus c. M is the slope of the line. That's true from junior cert when we were studying mathematics in second year. C is where the line cuts the y-axis. So y equals 3x plus 7 has a slope, dy dx, of 3. So if we have y is equal to 4x plus 2, we now know the slope of this line from second year work and third year work is minus 4. So when we do the differential, i.e. we work out the slope of the line, we know that it's going to be equal to the number in front of the x. Now, if we go back to our second year course, when we're looking at how to calculate the slope of a straight line, then what we do is we measure the y distance and we measure the x distance, and to work out slope, we divide the y distance by the x distance, and hence you can see how this notation came about. Slope function is now called dy by dx. We will now look at more complicated functions. We will look at functions of the form y is equal to x to the power of 4. Later on in the course, we will actually see y, the slope, is equal to 4x cubed. But for now, I need you to learn a simple rule. dy dx, the slope function for the equation above, is 4x cubed. If I've got y is equal to x to the power of 5, then dy dx is now equal to 5x to the power of 4. And in your formula books, there is a general equation. They say to you, if y is equal to x to the power of n, then dy dx is going to be equal to n times x to the power of n minus 1. It is best that you learn this formula in words. which is quite simply multiply by the power then minus 1 from the power. Consider the following example. Example 1. Y is equal to 3x squared plus 6x plus 5. We can apply the three rules that we have just looked at to each individual term of this quadratic expression. When I differentiate the y, I get the coding dy dx. When I differentiate a power of x, according to the rule up here, I have to multiply by the power, so I get 6, and then I put the power down 1. I minus 1 from the power, and I get a 1. If I differentiate a 6x, it's purely the number in front of the x, which is 6. If I differentiate a constant, I know the answer is 0. I don't normally write anything at all then. Let's just do one more example. Y is equal to 5x to the power of 3 minus 3x squared plus 5x minus 7. I'm going to differentiate each expression in turn, each part of this expression in turn. When I differentiate y, I get the coding dy dx. When I differentiate the 5x cubed, I multiply by the power, so I end up with 3 5s are 15, and it's going to be 15x squared. Here, I'm differentiating a power of x. When I multiply by the power, I get 6, or minus 6 to be more precise. And then I put the power down 1, minus 1 from the power, and I get a power of 1. When I differentiate a 5x, I have to remember it's the number in front of the x. And when I differentiate a number on its own, the answer is 0. And that is the end of that answer. Now let's consider the example 3 above. It says here, find the slope of the tangent to the curve y equals 3x squared plus 4x minus 5 at the point 1, 2. So the first thing I'm going to write down is what the equation is, the equation that was given. Y is equal to 3x squared plus 4x minus 5. I'm now going to work out the slope function. I'm now going to work out the slope function for this curve. When I work out the slope function, when I differentiate the y, I get dy dx. When I differentiate the 3x squared, I multiply by the power. So I end up 2 3s are 6. I put the power down 1, so it becomes 1. And then I'm now going to differentiate the 4x. When I differentiate a 4x, it's purely the number in front, which is 4. And when I differentiate a minus 5, the answer is 0, so I don't write anything. Now this is called the slope function. In order to find the value of the slope, then I have been given the point 1, 2. And this is the x value and this is the y value. So therefore I now know that x in this context is equal to 1. Therefore, I can substitute it in using the empty bracket method and very quickly get a slope dy dx is equal to 10. And indeed, I've answered the first part of this question. I found out the equation of the slope to the curve at the point where x is equal to 1 and y is equal to 2. The slope of a tangent, just to get you used to terminology, is the same as saying the slope of a curve at the same point, and is often abbreviated to just purely slope. Now, the second part of this problem, we actually were told, hence find the equation of a tangent at this point. Now, what I'm about to draw is a visual aid. It's purely a sketch. It's not meant to represent what was happening up above. This is the original curve, or represents the original curve, and this represents the tangent to the curve. At the given point. A tangent is a straight line which touches an object. So the key thing here is a tangent to a curve is always a straight line. And we've been asked to find the equation of this straight line, and we don't know what this equation is. Y minus y1 equals m on x minus x1 is the equation of any straight line. But we know from over here that the slope is equal to 10. We know that from here. So we can now advance this equation on. Y minus y1 is equal to 10 on x minus x1. What else do we know? We know that the tangent touches the curve at a point which is equal to 1, 2. Therefore, we know that 1, 2 belongs to the line. Therefore, we know that 1, 2 belongs to our line. So therefore, we can now label that x1 and y1 and substitute it into the equation below. So we've now got y minus 2 is equal to 10 on x minus 1. Then when we tidy this up, y minus 2 equals 10x minus 10. So y is equal to 10x minus 10. Bring the minus 2 over, becomes a plus 2. So y is equal to 10x minus 10 plus 2 is minus 8. And this is the equation of the tangent to the curve at the point 1, 2. So this is the equation of the tangent to the curve at the point 1, 2. And this equation is equal to y equals 10x minus 8. You are required to pause the video at this point, and you need to copy down all the equations on this page in the back of your assessment copies. You'll be using them over the next couple of weeks as we progress through this module of work. Let's look at what we've covered today. We've covered today that the derivative or the differential of a constant is always 0. We've also learnt today, if we've got y equals x to the n, then dy dx is equal to nx to the power of minus 1. N times x, where the power is n minus 1. Apologies. Please learn in words. We've also learnt today that if we want to find the equation of a line, then we have to quote this formula. Other key points today is we've learnt that slope is equal to n, that slope is also equal to this coding dy dx, and what we're about to see is that slope can also be written as f with a dash and then bracket x, and that is what we want to move on to fairly soon. Work that you were set last week was recognizing that if you have a square root, then it becomes the power of a half. If you've got a cube root, then the item becomes the power of 1/3. If you've got a fourth root, then it's 1/4 is the power. Here, if you've got a third root and you've got a to the power of 5 inside, then the 3 becomes the fraction at the bottom. Really important, remember this. And the other thing is that, again, from last week's revision, or last lesson's revision, 1/x to the 5 can be written as x to the power of minus 5. It's really important that you actually learn that. Now on this page, we're going to have a quick summary. Once again, the slope of a constant is 0. The slope of a straight line is the number in front of the x. So if we've got y equals mx plus c, then the slope function dy dx is equal to n. We've also covered in this module of work that if we have a power of x, i.e. y equals x to the power of n, then dy dx is equal to, well, you multiply by the power, bring the power to the front, and then you take 1 away from the power. And it's very, very important that you learn that in words. As on the previous page, a quick reminder as to what these items here actually mean. Algebraically, they mean x to the power of a half. Here, algebraically, it means x to the power of 1/3. Here, y is now can be rewritten as x to the power of 1/4, and here y is equal to x to the power of 1/8, and finally y is equal to x to the power of 5/3. We're now going to differentiate each one. When I differentiate a y, I get dy dx is equal to multiply by the power, and then we put the power down 1, i.e. take away 1 away from the power. When we put it down 1, the new power becomes minus 1/2. Let's skip up to this one here, because they're all roughly the same. When I differentiate y, y becomes dy by dx. You must remember that, very important. I'm then going to multiply by the power, and then the power goes down 1. If I take 1 away from 1/8, I end up with minus 7/8. And finally this one, when I differentiate the y, I get dy by dx. When I differentiate a power of x, I multiply by the power, and then I put the power down 1. So if I take 1 away from this power, then the answer is going to be 2/3. So I'll now go back to this table here, and I'm differentiating a constant. If I differentiate a constant, then the dy dx is going to be equal to zeros. When I differentiate an ordinary x, I have a look at what the number in front is. The number in front of an x is in actual fact 1, so therefore the slope dy dx is going to be equal to 1. The number in front of 2x is 2, so the slope is going to be equal to 2. The number in front of minus 3x is going to be minus 3, so dy dx, the slope value is minus 3. The slope value for a power of x is multiply by the power, put the power down 1, multiply by the power, and put the power down 1. These ones here I've already done down there. I have got one more example to do. When I finish completing this example, you will be able to do the exercise above and the question numbers that I'm going to indicate after I've completed this example. I'd like you to consider the function. Instead of writing it as y, we can write a function as f of x. We saw that back in third year. And I'm going to say let f of x equal 3x squared minus 6x plus 4. And there's going to be two parts to this question. Part 1, find f dashed x, and then part 2, evaluate f dashed 3. Let's take part 1 first. We were given f of x is equal to 3x squared minus 6x plus 4. That's what we have been given. Now, what we saw earlier on, that there are different ways of writing down slope. Slope can be written equal to n. Slope can be written equal to dy dx. Please learn that expression of saying it. It's dy by dx. Language is important. And finally, the last bit of notation is slope is equal to f dashed. So when they require us find f dashed x, it means find the slope function. And the slope function means differentiate. How do we differentiate? You multiply by the power, and we end up with 6. And then we put the power down 1. So 2 goes down 1 to 1. When we differentiate minus 6x, all we do is we lose the x. So we're left with minus 6. When we differentiate a constant, that's the very first thing we did today's lesson, it becomes 0. So we don't bother writing it. Part 2 is asking us to evaluate f dashed of 3. So our function at the moment is f dashed x is equal to 6 times x. We don't bother writing the power of 1. We just leave it as 6x. And they've asked us to work out f dashed 3. And it's fairly obvious when we place it and line it up underneath. What we're doing is we're replacing the x by the 3. So 6 on 3 using the empty bracket method. So 6 3s are 18. 18 take 6 is going to be 12. So f dashed 3 is equal to 12. Now it's very important we can translate this into English. You know, it's important that we learn what does f dashed 3 mean. And what it means is the slope of the function at x equals 3 has a value of 12. So the slope of the function f of x has a slope of value 12 at the point where x equals 3. Now, the questions I want you to complete for homework are as follows. I want you to complete question number 1. I also want you now to complete question number 2 after that last example. Question number 4. Question number 11, all of number 11. And finally, question number 17, the first from numbers part 1 to part 9. From numbers part 1 to part 9. So question number 17 from part 1 to part 9. As an extra question, I would appreciate it if you also did question number 16. If you also did question number 16, do not do question 19.